Hello, everyone. This is the project demo for EE542, the final project. And our project topic is IoT based farm animal monitoring. We are the team leapfroggers, and our team members are Anand, Parth, and me, Prasanna. So I'll move on with the demo. So here first we will go into the product overview and see a real world scenario as to where our product might come in handy.
I can see my 3 cows and 3 goats. I will leave them for some while.
2 hours later.
Oh no. Where did rest of my animals go? Hi, I am facing a trouble. Some of my animals are getting lost in the open fields.
That is unfortunate. Maybe I can come here and provide a resolution for this.
So, with Animaps, what we're trying to achieve is that we're trying to help our farmers by notifying them whenever the animal is closer to the farm boundaries. And what we're also planning to do with the Animaps is to provide historical data to analyze grazing patterns and physical wellness so we can analyze how the animals are doing at different points of time. But to be able to understand our problem statement better, we need to find out why our farmers would need this, and if they actually need a product like this, and how this product can bring a difference into their lives. So let us see what data tells us about livestock in farms. So, the idea of having a monitoring system in a farm is not just about safety alone. So, what is very commonly analyzed in these farms is that 95% of the animals do not need any intervention in their daily lives or daily routines because they'd be going about their own ways and minding their own business. But what we do is that if we do not have a concrete monitoring system, we basically try to interfere into their lifestyles and life patterns. And what these animals do is that if they do not have any interference, they can have greater productivity. For example, cows are known to lactate more and provide more milk if you let them graze by themselves and like have their own schedule and just be there for the milking phase. So, what we also did was to try and see why a monitoring system would come in handy. And the common perspective is that the farm animals would just be needed to be protected from outside interference, and there you'd actually not need a monitoring system for anything else. But the U.S. the cattle death laws from 2010 suggests that the carnivore caused deaths were just around 0.3% or 0.23% of the total cattle that is present in the U.S. And the other deaths are what like make up the majority of majority of all deaths of cattle. So you'd see that 4% of the cattle deaths are from other causes as compared to 0.23% for carnivore caused death loss. How can tracking help all of this? By ensuring that the livestock stays in farm, you're gonna be able to make sure that they're under monitoring and under safe conditions all the time. By predicting their behavioral patterns, you'd be able to isolate which animals require more attention and which animals do not require any attention. And you can basically let go most of the animals that saves both a lot of time and it also increases productivity within the farm. How does this help? So when we go into a we do a deep dive into what bothers livestock and what are the common problems as to why sheep lose their lives. So here you have health complications, lambing problems, old age, on bag, poison, theft, and weather. So if you'd see by by tracking the movement patterns, you'd be able to identify changes in weather. You'd be able to identify through old age a reduction in the movement. If there are any health complications, then you would see lesser movement in the animals. So by being able to analyze tracking patterns and the amount of movement that a particular animal has, you'd be able to better predict whether a livestock is bothered or whether it is impacted or whether it needs attention or not. So, how does Animaps come into all of this? By providing a monitoring system where basically providing the utility to a farmer to be able to track all of these issues better. And with Animaps, you are able to track whether an animal is in the farm a little more accurately than the other systems. This is usually through the geospatial detection in our system, and Parth will be talking more about this later. The behavioral analysis that we do to try and understand whether an animal is functioning normally is through the location history. And with the presence of a multi-tech conduit, we're able to work within a 10-mile radius in the line of sight, which means that you'd be able to cover large farms and a large number of animals. And because it is low maintenance and economical with the use of an XDOT, you'd actually be able to scale and track a lot many animals very effectively and gain more out of the system. So let's go further into trying to understand how Animaps works. What are the technical details and how much it costs?
Okay, so now I'll be talking about the technical specs of Animaps. So let's dive into it. So here is our proposed model where we have a farm consisting of many animals, and each animal in the farm will be tagged with an X dot and a GPS module. So there will be a conduit for creating the network gateway, and all the GPS units will provide data periodically through the multi-tech conduit. So over here, we'll define a boundary which will act as a virtual fence of the farm. And whenever an animal is found too close to the boundary, a real-time notification will be triggered in the form of email or SMS. So now we'll talk about the geospatial mapping. So whenever we are dealing with the spatial data, we have to consider two things. One is a point, another thing is a polygon. So what is a point? So a point, it is used to represent non-adjacent features and to represent discrete data points. It is an atomic component when we are dealing with geospatial data. It comprises of latitude and longitude. And when we are talking about polygon, polygon is used to represent areas such as a boundary of a farm or a lake or city, etc. A polygon is made by a collection of points. So in our case, we use our USC campus and we use the discrete point data to store and create a geospatial polygon out of it. We used our current location to identify whether our point was inside or outside the polygon. This was done using the PostGIS extension for Postgres. So now let's dive into the code, the Node-RED thing. Here, what we have done is we have installed a turf library in Node-RED, which help us to perform spatial analysis. Here we had to give a polygon in the form of multiple points. So each a polygon will have multiple points, and each point will have a latitude and longitude value to it. The other thing we did was at EC2 instance, we had to use PostGIS extension for Postgres. We had to use this as we have to store some geo coordinates in the database, and adding this PostGIS extension provides a facility or a feature to the Postgres database. So in case we found any animal outside a polygon, a notification will be triggered, and the farmer will be was found outside the fence.
Hi. So now let's see what we do with the GPS data. So once we collect the GPS data, we aim to put it on the cloud. So the GPS data provides a wealth of information on into the animal's behavior and its health. So once we get the GPS data, we put it on a DynamoDB and use an AWS instance for further analyzing. What can we infer now from the GPS data that we've collected? So first, we can identify the grazing times and patterns to see if an animal has a particular pasture land they prefer. A group of animals prefer a certain pasture land, and if certain grounds or pastures are grazed or overgrazed, and where to direct these animals. Another thing that we can infer from the movement tracking is health abnormalities such as lameness. If the animal isn't moving for long periods of time, it usually means that it has an abnormality. It also sheds light into animal husbandry details that a farmer needs for further propagation of livestock. So for all this, we need individual tracking to ensure that it is the animal that we are tracking. And this can be done on Animaps with our integrated dashboard to view this information. Okay, now let's see the hardware specifications for Animaps. First, we have our multi-tech conduit, which is a range extender, and it has a coverage of 10 miles, which is covers a lot of area. Next is the geospatial location tracking, that is the GPS data from our GPS module, which is tracked once every 6 minutes. And once we get this GPS data, we put it on our DynamoDB and use it for analyzing this information. And it stays there for 7 days. Then for power consumption, we have the power consuming devices here is an XDOT and GPS, and we will require a battery. With 4 AAA batteries, we can power this XDOT and GPS module for up to 5 years. Okay, next comes cost analysis. So let's see. Uh, First, we have our XDOT, which costs us $5 per unit. And then we have our GPS module, which costs us as less as $2 per unit. Then the the cost for our product comes from the multi-tech conduit. The conduit is $500 per unit, but if we split it over the first year of our subscription, it will only cost $40 per month. Then AWS, we plan to charge the customer only $5 per month for storing the GPS data on AWS and analyzing the GPS data. Then to power the device, we will require Duracell batteries or any batteries, and that would cost the consumer only 25 cents. Finally, to get notifications on Gmail and use our interactive dashboard, it's free. Okay, so the cost rundown is the service cost of $10 and 25 cents for each animal monthly, and the hardware cost is $40 per month only for the first year. The GPS tag cost is $10 per animal, and that's a one-time fee. Okay, so that is our cost analysis. Let's see who else does it in this in our industry. First is Lone Star. So Lone Star offers a single GPS module. They do not do any analysis, nor do they provide any dashboards, and they also charge a $60 for fixed fee at checkout. And on top of that, they have a $14 monthly fee to keep this GPS information from animal tracking coming. So our product does all the things that they do and more, much more economically. Next is Yabby Edge. So we beat Yabby Edge on the features over cost in 1.5 years. And Yabby Edge uses satellite data to track, and that is updated only once every 2 hours. We track our animals every 6 minutes. Also, Yavi Edge has $7.95 per month and have a $65 sign up fee. Finally, we have Movement. Despite their clever name, they don't come close to us either. Um, they do offer interactive dashboards for animal tracking, but we do beat them on price. And we offer a much more interactive dashboard and more features. So that's our cost analysis. Next person now will demo our product. Thank you.
Now that we have seen how our product works in comparison to our competitors, let's see the product itself. So the first part of the demo shows how the GPS tracker works and how it triggers mail notifications when you walk out of a certain predefined boundary. So here's the first part. So here you can see the layout of my house on Google Maps, and we have basically set out the coordinates for 4 different corners of this boundary to set as the boundary of the farm. And the time right now is 5:57, just to make sure that we're able to show you the notification at the right time. Here we have the Node-RED setup that we showed as part of the first video demo. And here we have updated the coordinates of the 4 corners of my housing complex so that we can monitor the tracking of the GPS. So now we will go on to our GPS module, which is like a little more portable as compared to the last time. Here we have Anand as our rogue animal for the day. And you see the setup. This setup basically now is currently being powered by a battery pack. We intend to switch that out for. So yeah, right now Anand has just exited the complex and he's outside of the territory. This is our setup. And now I think I should be able to go back and find Parth to see if the mail notification was triggered for this. So here we have the notification triggered, which says farm animal alert. And just around 0 minutes ago at 5:58, we have a mail which says that the animal with GPS ID was outside of the fence. So before going ahead, I want to show you how the UI looks and how our product looks right now. So right here, I have the whole setup with me. So this is the multi-tech conduit right now that is functional and that is continuously taking input from the X dots. And the X dots in itself are a much more compact and portable setup right now. So this is how our product looks. So here, if you see that right now, our product is powered by an AC cable, but the whole setup in itself is very portable and it works with a power supply circuit. So the power supply circuit is powering the X dots, and if you can see, the X dots do have a continuous input coming in. The GPS is also taking out power from the power supply, and this power supply circuit can be powered with AA, AAA batteries, as Anand has already mentioned. So, and the GPS is continuously providing input to the X dots, and the X dot is sending that input through the conduit onto our UI, which is right here. And the last part, if you see, the ports that we are using in the X dot are number 13 and number 14, to which we have wires soldered. So the UART-TX and UART-RX port is what we're using for the X dots to get our input. So right now we have the Animaps UI, and here you see that we purchased 2 X dots, and both of them were used to track different items. And how we actually analyze the grazing time is by marking certain coordinates as a grazing field. So in this particular house, what we did was that we marked this particular part as a grazing field part, which was like the other side of the house. So well, you see that like for the last 20 minutes we have been stagnant in this particular position. So when I added this particular item, it says that it was grazing for the last 20 minutes. Now, the X dot that was just started in the other room recently, let me just add out another entry for that. So let's call this one Levine, going by our first one, and the GPS ID to be 1. So 10 minutes is what it should show as its data. So here you see that this sheep was tracked again since right now. And what we have done is that when you enter a GPS ID, that particular GPS ID is mapped to whatever data entry is coming in from the AWS database. So we have a Node.js backend that actually makes a server call and queries the GPS data for that particular ID. And it also provides the grazing time analysis by checking out the database entries, the last 10 or 20 database entries for that were made within that particular geospatial location, which again had its own triggers, as was shown in the Node-RED flowchart. So this is how we intend on showing our the tracking of our animals, and that is how the Animaps UI looks. So going ahead, what we want to see is how we got to where we are right now. So within the first week, we set up the software side of this project and set up the geospatial location monitoring calculation. For the second week, we set up the hardware and hardware to work to have the GPS integrated with the X dots. Getting them to work together was pretty tedious, and we had to spend some time trying to figure that out. The next part was to try and integrate the software side of the geospatial mapping and make it work along with the XDOT. Once that was done, what we did was that we added a continuous filter, like a continuous thread to update the location from every 6 minutes onto the AWS system, and then use that data on the backend Node.js backend to be able to analyze the amount of time that we spent that the animal spent grazing by picking out data from how long was that animal in that particular zone that we marked as a grazing zone. Going ahead, what we can do is that we can extend this whole idea into an IoT based smart farm with a lot many more sensors, and transcend past like helping out farmers through livestock only. And this can be done through various soil and climate detection centers, like sensors. And we could add like cameras to probably enhance the animal protection by providing detection against wild animals, because we already have the AWS setup and everything else working around with it. So this can come as an upgrade on top of whatever plans we are offering for animal monitoring. So the last part would be our project references. So we used multiple research papers. The first parts were just to try and understand and see if we had a market for our idea, and whether we can use the tracking systems for for tracking systems for our particular use case for livestock. And then there were a lot of papers that we had to reference for trying to understand how we can utilize the GPS data to help animals, and try and understand their behavioral patterns using that. And that is where we got the idea that that if we mark particular grazing fields, and then we try to query on a periodic basis to see which animals were where, then this would happen. Another thing that in the website that I forgot to mention was that the website continuously refreshes once in every 10 minutes, and it queries for the latest coordinates, and the coordinates change as per wherever it is shown on the UI. Right now, these coordinates are fixed to my house because the X dot is in my house. But if we actually move around with it, probably to the edge, like for the next refresh, we'd be able to see that this particular location spot moves here. And apart from the references, like we also looked into the navigation systems of drones and other things, like just to understand the working of GPS data a little better, because we had a lot of trouble trying to figure out how to use the GPS data with animals in a coherent way. Working on this project was a real delight, and we had a lot of fun making this presentation and getting this little chipset to work together. And it is really amazing on how we were able to send through data continuously and have that data being reflected in AWS, and being able to use knowledge that we inherited from different parts of the this particular course to actually come up with a working solution that can solve a real life problem. We hope to take this project forward and probably take this someplace better if all three of us have the time to sit with it together. Please feel free to reach out to any one of us on our particular emails to ask us more about how we did this particular project. We'd be happy to respond on any changes on modifications that could actually help us make this better, or clarify anything that we did to actually get our project working. Thank you so much.